Now that we've talked about groundwater, let's discuss surface water. Surface water is again exactly what it sounds like. This is water on the surface. So this is going to include streams, rivers, lakes, and reservoirs. Okay, so how well the water actually drains into the ground, this is what we refer to as infiltration. Okay, the infiltration of water is going to be determined by the intensity and duration of precipitation. If you have a very fast, heavy rainfall, not as much is going to be able to sink down into the soil, into the groundwater system, so a lot more will stay as part of the surface water system. Okay, it's also related to the prior wetness of the soil. If the soil's already wet, there's already water there. It's not going to be able to hold as much. It's determined by soil type, related to permeability and porosity. The slope of the land, a shallow slope will allow water to settle on and sink down over a longer period of time. A steeper slope means water is going to run fast off of it, so less actual infiltration. And then also the nature of the vegetative cover. In other words, how many plants are there? Plants can actually affect the amount of rainfall. I know that in certain regions where they have really steep hills, they actually like to have a lot of vegetation there to help reduce the infiltration. Because if there's lots and lots of water, then it'll turn into mud and actually create a mudslide. So running water actually affects the earth in two different ways. One, it actually carves the landscape, actually carving channels and so on, but it will also deposit sediment. So in one way, it's breaking stuff down. In another, it's actually depositing. So water, surface water, tends to break down high areas and fill in low-lying areas. In other words, it has an overall smoothing effect over the surface of the earth. Now, something that affects how fast water flows is what we call the stream flow geometry. So the stream flow geometry is what is the shape of the stream, and that's going to determine how well the water flows. So some things that affect the velocity of the stream, we have the gradient or the slope. If you have a shallower slope, then it's going to generally go more slowly. If you have a steep slope, it'll tend to go faster. Something else that affects it is the discharge. So the discharge is the volume of water moving past a given point in an amount of time. In other words, how much water is actually passing through. And then last, we have the channel geometry characteristics. So what does the channel that the water's flowing through actually look like? What is its shape and its size? So the average stream speed is equal to the discharge, remember that's the amount of water going through an area at a given time, divided by the cross-sectional area. Notice that the average stream speed is proportional to discharge. In other words, the greater the discharge, generally the faster the stream speed. But it is inversely proportional with the cross-sectional area. So the wider the stream is, the slower the stream speed tends to be. Now, stream speed actually varies within a given channel. So that equation we just saw was for the average stream speed. As we look along a channel, we actually see that along the channel we get different speeds. Along the edges and the bottom of the channel we get more friction, and with more friction we tend to get slower movement. Towards the center of a channel where there's less friction, we're going to get the maximum speed. I know that when I was a kid, I would throw rocks, or not rocks, but leaves and sticks into a river or a stream, and the stuff that was closer to the middle always went faster than the stuff towards the edges. Now, if we have a curving channel, that changes the overall geometry, and in this case, we have a faster speed on the outside bend and a slower speed on the inside bend. And so the flowing water actually sculpts and shapes the surface. As we've mentioned previously, it tends to cut channels, which also leads to erosion, moving that sediment from one place to another, and then we get deposition where it's actually depositing material. So what helps to determine the how much material the stream can carry is the stream flow. Stream flow comes in two types. There is laminar flow. This is slow and gentle with all of the water actually moving all in the same direction. And then there is turbulent flow. This is fast and rapid and tends to have kind of a swirling, churning motion to it. Okay, so if you've ever gone river rafting, the rapids usually have turbulent flow, and then the calm regions usually have laminar flow. Okay, well, laminar flow, because it is gentle, it has less energy, so it's not able to pick up as much material. Okay, so it's only able to carry the smallest and lightest particles. Okay, so things like silt. Turbulent flow, because it's moving faster and it also has this churning motion, is able to actually pick up and carry even large pieces. Okay, I have not actually experienced, but I have heard that rapids are most dangerous if you fall into them, not because the water itself is moving fast, it is, and that's dangerous, but because it's carrying large rocks that can crash into you. Okay, so you have these big pieces that are also churning and tumbling within the water because turbulent flow has a lot more energy. Some other things that water is going to be doing during this is it can actually provide chemical weathering. So if you remember from previously, chemical weathering is the breaking down of rock through chemical processes. Okay, so rainwater is slightly acidic, which means that river water is also going to be slightly acidic, which can dissolve and erode rock. We also are going to get hydraulic action. Okay, this is erosion and movement of large amounts of sediment and rock as this material is flowing, and this will also lead to abrasion. Okay, so we're going to have all of these particles within the water, and as the water moves through, those particles are going to scrape along the sides. Okay, so it's going to scour the channel. Okay, so stream erosion is going to pull away loosely held particles. Okay, and then strong currents will also pick up material. Bigger, heavier things that can also knock and break off other pieces. Okay, so generally, a stream is going to create a V-shaped valley. As the water comes through, it always sinks down to the lowest point and cuts this V-shaped channel as it's flowing through. Okay, this can also lead to pretty things like waterfalls. Now, we already mentioned this, but the stream speed is going to affect how much material the river is actually going to be able to carry. Fast-moving water has higher energy, can carry bigger and more stuff. Slower-moving water isn't able to carry as much. And so depending on the stream speed will determine whether we get erosion or deposition. So when looking at a meandering stream, so one of these rivers that's curved, we've already mentioned that the outside edge, the water is moving fast. Because the water is moving faster on this side, it's going to lead to erosion. So this is what we refer to as the cut bank. The cut bank is a region of erosion because the water is moving faster. On the inside part of the bend, the water is moving slower, and because it's moving slower, it actually leads to deposition. So this creates a point bar. This region of deposition. So we have one side that is being cut away, and the other one is actually being deposited. Meandering streams can also create what we refer to as flood plains. So as the stream actually swings back and forth, so over long periods of time, these rivers don't actually stay in the same place. Because of erosion and deposition, they actually meander going back and forth. So as this happens, it's going to fill in these low-lying areas with a lot of sediment, which is a floodplain. If we get a lot of water running through the river, more than average, then will actually spill over its bank and flood the entire flood plain, which is why we call it a flood plain. The last thing that we see for deposition is a river delta. A river delta occurs as the river flows into a sea or an ocean and it suddenly slows down. When that water suddenly slows, then it is going to deposit all of the sediment that it was carrying. Okay? And because of how the water is spreading out, it tends to make these fan-shaped regions. Okay? So we refer to these as deltas because some of them actually look more like a triangle. Okay? So these are river deltas. So here's our third clicker question. What happens on the inside bend of a river? A, erosion, B, deposition, C, uplift, or D, none of the above. Go ahead and think about it and we'll discuss it in just a second. All right, now that you've thought about it, what happens on the inside bend? The inside bend is where the water slows, and as the water slows down, it has less energy, so we get deposition. It's actually going to start depositing material. And one more because I mean like that. Here's question number 4. This picture shows an example of what geologic feature? A, floodplain, B, delta, C, turbulent flow, or D, rapids. Go ahead and think about it, and we'll discuss it in just a second. All right, so looking at the overall shape of this, notice that it is generally triangular. It's got this kind of fan shape. We also have the river leading out into the sea. Specifically, this is actually the Nile River Delta, so this is the Mediterranean Sea up here. Okay, so this is a river delta. Okay, so a river delta, the correct answer is B.